Hello, my name is Nadieza, and this is my example problem for Math HL November 2013, Paper 3, Problem Number 2, Example. So the question states, the general term of a sequence, known as an, is given by the formula an is equal to e raised to the n plus 2n over t 2 times e raised to the n for all n that is a positive integers. So our first part of this problem, which is part A, says to determine whether the sequence is increasing or decreasing, and this is a 3-point problem. So there are multiple approaches to this problem, but to make sure that we get all of these 3 points, we have to first say whether it's increasing or decreasing, the sequence is increasing or decreasing, and then prove how we know this. So the first way to do this is to show that one term is less than the subsequent term. So an is less than a or greater than an plus 1, or you can say an plus 1 is less than an. As you can see, I have this proof written on my sheet of paper, and you can also reference that if you rewrite the sequence as 1/2 plus 1/2 times 2 over e raised to the n, you can see that it is a geometric sequence. And the value of 2 over e, if you put it in your calculator, since this is a paper 3, you can say that it is less than 1, and we know that when the geometric ratio is less than 1 in a geometric sequence, that means the sequence is decreasing. So that is also another way you can prove that this sequence is decreasing. The second step that you can use to prove that the sequence is either increasing or decreasing or to prove that the sequence is decreasing in this case, is to take the derivative of the function, because you know that the derivative will give you the value of the slopes of the function, which will determines like its direction. So I simply use the quotient rule in this case.
Oh my god, I'm gonna turn my head anyway, the camera's right by my face.
You're gonna mute this, right?
Yes. I almost jumped. Almost. Took a lot of self-control there.
Jesus, it's long.
Hoodie high minus high heel over ho squared.
Ho ho.
Oh no, I forgot a step. I have to state that this is f of x. Ooh, I'm a dummy. I'm a dummy.
No, you're not.
No, I have to write this on the side. Okay. Really important. They won't give you any credit unless you state that this is f of x.
So this is the integral text?
Also, before I forget, oh my goodness, before you take the derivative, you have to state the sequence in terms of a function. So as terms of f of x, IB is really strict about this, and they will not give credit or any points if you don't write the sequence as a function.
Back to this.
I got a headshot of you. Pensive.
So we can
Deep in
cross out, divide out this, and divide out this, and take out that. So now this is equal to e to the x. And 2 times 2 to the x. Minus e to the x. Plus 2x. We can say this cancels out with this. So now we just have ln 2. Oh, all of this over 2 to the e to the x. We have ln.
Take the natural law again.
I'm so bad at this. What am I doing? Oh yeah. You have ln of 2 minus 1. I'm so bad. I factored out the 2 to the x. There we go. Over
Wow.
2 to the e to the
This is
x.
good now.
Okay.
As we simplify this derivative, we get that the ln of 2 minus 1 is a negative number. You can put it in your calculator. It's negative 0.307. So since the derivative is negative, we can say that the sequence is decreasing.
Never.
You have to write it.
Then we do zoom in on your face, underline.
So we're going to try to find out. L is going to be equal to. It's so easy when you kind of talk it out. We're going to say that L is equal to the limit of n to infinity of our sequence.
Part B of the problem, which is only worth 2 points, so you can already tell that's going to be pretty simple. It just says that show that the sequence is converging and find its limit L. So to find the limit of this sequence a to the n, we're going to take the limit of n to infinity of our sequence. So it's the limit of n to infinity of e raised to the n plus 2 raised to the n over 2 times e raised to the n. And we can rewrite this as 1/2 plus 2 over e raised to the n. And before I forget, I need to multiply this by 1/2. There we go. And if we look as n approaches infinity of 2 over e, it's going to become a really, really small number, and which is essentially just 0. So we can rewrite this as 1/2 plus 1/2 times 0.
That really cute girl that just walked past.
And that is just going to be equal to 1/2. And that is our limit. Next part. And for the last part of this question, part C, it's worth the most points. We're going to find the smallest value of n, which is an element of all positive integers, such that the difference between our sequence and the limit is less than 0.001 or 1,000 or 1 over 1,000 for all n that is greater than this number. So first we can write out the sequence like this, and
It's too spicy.
we can begin to simplify. So we get 1/2 times 2 over e raised to the n is less than 0.001 or 1 over 1,000. You can rewrite that.
That's probably like a bad way to rewrite it.
I'm going to continue to simplify this problem down until we and also move some of the terms around
rearrange our equation because we are solving for n.
I can say, so we get to this point, which
we're gonna
is
get 2 over e to the n is less than 1 over 500. Correct?
Correct.
Okay. Now, I still don't kind of like how this is looking. Let's see. Actually, you can stop. I think you can just plug it into your calculator now and just go.
If I could have stayed there and worked there next year, I absolutely would have. I'm sorry.
so I can write that 2 over e raised to the n is less than 1 over 500. I'm going to move the 500 over to the other side. So then I can say that 500 is less than is less than 1 over 2 over e to the n. Or really, we can just flip our fraction over there and say that 500 is less than e over 2 raised to the n. At this point, we can't really do much to simplify other than use our calculator, but this is a paper 3, so it is completely allowed. So you can open up numeric solver, still leave your calculator in sequence, and once you listen to your calculator, you should get 20.25 for n, which, if you have to use integers, it'll be n equals 21.